All right, so let's move on to the next topic. So this is 4.1, non-linear relations. So we're basically getting into the idea of relations that are not going to be straight lines anymore. But just to recap, just so we don't lose track of what we knew before, we do know that a linear relation had this form y is equal to mx plus b. Now we call this the standard form for a line. This is the standard form equation for a line. This was the standard form. Now, any linear relation always has a degree of 1. What we mean by that is the power of x inside that equation, y is equal to mx plus b. The power of x right here is a 1. Right? It's never going to be more than that. It's never going to be less than that. No, that's not true. It could technically be less than that if it is a vertical or horizontal line, technically. Or, I guess, yeah. Okay. So let's ignore that for a second. So let's get on to the next piece. Now we've seen this equation before. Let's take our little highlighter here. We've seen this equation before. Y is equal to ax squared plus bx plus c. We saw this in Unit 5 when we were discussing factoring and all those kinds of things. Why is this not letting me go here? There we go. All right. Now, when we see an equation in that form, this is called a quadratic relation. Quadratic relation. It's of the form y is equal to ax squared plus bx plus c. This is the standard form for a quadratic equation. This is the standard form for a quadratic equation. I don't know why it's not letting me show that R there. Now, this only works if a is not equal to 0. Imagine a was 0 here. That would be 0 times x squared, which would make this whole term 0, so we would just be left with bx plus c. Oh, that's the same thing as this. So if a was 0, that means we'd actually have a line again. So when we're talking about a quadratic equation or a quadratic relation, we always have a degree of 2. If we don't have a degree of 2, then it's not quadratic. It's something else completely, and we'll learn more about those things later on. So a non-linear relation, so basically anything that is in a line, is when a constant change in one variable, the independent variable, so as x changes, remember x is, and the independent variable is the x-axis. So as x changes, it does not produce a constant change in the dependent variable, which is the y-axis. Whereas when it was a straight line, it always produced a constant change. We saw this because we saw the first differences, and all the first differences were exactly the same. When you graph this, so when graphed, the relation does not produce a straight line. It's going to produce something we've already seen before, but we didn't know. So the differences created from a table of values can determine the type of relation that exists. So when we do a table of values, such as the one down below here, if we calculate the first differences and then the second differences, which is really just the difference between each row of the first differences, that will tell us whether it is a linear relation or whether it is a quadratic relation. Let's demonstrate. So we can look at that equation right now. We already know, because it fits the format of y is equal to mx plus b, that that's going to be a line. But we're mathematicians. Our job is to prove it. We can't just say it. We have to prove it. That's the rule. So we're going to take this -3 and we're going to substitute it into this equation, and we're going to calculate our y component. So 2 times -3, that gives me -6. -6 plus 3, that's going to give me -3. All right, let's go to the next one. 2 times -2, that's -4. -4 plus 3 is -1. Okay. Now, when we do -1, 2 times -1, that's -2, plus 3 gives me a value of 1. 0 times 2, that's 0, plus 3 is 3. 1 times 2 is 2, 2 plus 3 is 5, and 2 times 2 is 4, 4 plus 3 is 7. Okay. Let's graph our curve, and then we'll come back and check out the first differences and second differences to kind of validate our information here. So we're going to start off with our first point, 3, -3. So over 3, so left to the 3 and down 3. That's going to give us a point right there. Okay. Now, -2, -1 right here. -1 and 1. 0 and 3. 1 and 5. 1, 2, 3, 4, 5. Did I miss something here? I did. That one is in the wrong spot. You're in the wrong spot there, dude. Fix. There we go. Let's go back to where we had it. So it was -1 and 1, and then it was 0 and 3. I almost got it in the wrong spot there. Okay. And then 1 and 5, and then 2 and 7. Way up here. We draw our line. We label our axes, and we label the relation. Y is equal to 2x plus 3. And now we can look at that. We can clearly see it's a line, but again, we have to show it. So let's check out our first differences. So we take our y value and subtract the y right above it. So -1 minus -3. So these ones work together here. So -1 minus -3, that's the same thing as -1 plus 3. That's going to give us 2. Okay. 1 minus -1, that's also a 2. 3 minus 1, 2. 5 minus 3, 2. 7 minus 5, 2. Oh. So we can see that the first differences are constant. So since the first differences are constant, that tells us that the relation is linear. But we have this second differences column. Let's see what it looks like. Basically, we want to know the difference between each of these components. They're all the same. So if we do 2 minus 2, we get a 0. 2 minus 2, we get a 0. So in this case, whenever it's linear, your second differences are always going to be zeros because you're basically subtracting the value from itself, so you end up with 0 again. So that's our first one. Obviously, this is still just a line. Let's go on to the next one. We got a bunch of examples for today's lesson. So we're going to try and go through, I guess, all of them, even though it's kind of repetitive. You can fast forward through the bits that you don't want to watch or you already feel comfortable with. So this is still the same idea. We still have a relation, and our job is to determine whether it's linear or nonlinear, linear or quadratic. But again, we can look at it, and we should be able to tell because it has a degree of 1. So that kind of tells us everything we need to know. But let's do it anyway. So we're going to take our -3 and we're going to substitute it in here. So that's -3 over 2. Let's show what this actually does here before I kind of go through each one of these. So if I have y is equal to 1/2 times -3, and we're going to substitute our -3 in here, and then minus 5. Well, that's the same thing as -3 over 2 minus 5. Now I can look at that and I can say, well, I can see that that's clearly -1.5. Now I subtract from this, that's going to give me -6.5. Right? So if we wanted to go with decimals, we could be just done here. If we wanted to keep it as fractions, well, we got to do a couple extra steps. We got to get a common denominator, -3 over 2, subtract 10 over 2, and we'd end up with -13 over 2. So it depends on what you want to do. When I'm graphing, I find it easier to work with decimals than I do with fractions. So either or, depends on what your comfort level is or what you're requested to do. In any case, we'll keep it as a whole number now, so we'll just say -13 over 2. Okay. Now, if we substitute -2 in there, I'm not going to do all the calculations for all those. I'm just going to demonstrate this. So y is equal to 1/2 times -2 minus 5. So that's the same thing as saying -2 over 2 minus 5. Well, that's -1 minus 5, which is just -6. Okay. So that's -6. Now, if I keep going and I keep doing this over and over again, I'm going to end up with -11 over 2, and then -5, -9 over 2, and then -4. Okay, we can graph this. Let's try it. -3, and then -6.5. All the way down here. Okay. And then -2, -6. Interesting. -1, -5.5. Where'd it go? Right about there. 0, -5. 1, -4.5. And then 2, -4. All right. I guess we just draw our line now. Don't forget your arrows, your axes, and label it. Y is equal to 1/2 x minus 5. So again, let's show our first differences because we have to validate this. Oh my goodness. Okay, so we have to do this. So this is saying -6 minus negative 13 over 2. Well, I need a common denominator, so that's going to be negative 12 over 2 plus 13 over 2. And that gives us 1 over 2. So our first difference would be 1 over 2. Whoops. 1 over 2. Now, if we keep going, we're going to find the exact same thing. Oh, why is it getting all weird on me here? Stop that. Where's my eraser? Let's get rid of whatever's going on here. So we'd end up with 1 over 2 for each one of these. And our second difference is a half minus a half is 0. Half minus a half is 0, 0, 0. So we can see that our first differences is constant. We don't need to look at second differences because first difference is constant. So since the first difference is constant, that means the relation is linear. Okay. Now we were able to tell it was linear through 3 different ways. We could look at the equation itself and look at the degree. Yes. We could see it's in the form of y is equal to mx plus b. Okay, that tells us it's linear. We could look at the line, which is clearly a line. That tells us it's linear. We could look at the table of values and see the first differences are constant. That also tells us it's linear. So let's go down. Let's do the next one. Let's throw a monkey wrench into these things. So now we have y is equal to x squared. It's important that you remember that that square applies to the entire value of x. So for this first one, what we're really saying is here is y is equal to negative 3 squared. That negative 3 is part of the squaring. It's not outside. It doesn't happen after. It's part of the squaring itself. We're substituting negative 3 for the x itself. So this ends up with a 9. And then we get 4, 1, 0, 1, and 4. Okay, let's do our differences right now. So we got 4 minus 9, that's going to give us negative 5. 1 minus 4, negative 3. 0 minus 1, negative 1. 1 minus 0 is 1, and 4 minus 1 is 3. Those aren't constant. That doesn't help us. Okay, so we know it's non-linear. Let's go to the next one. If the second differences are the same, that tells us that it is quadratic. So negative 3 minus negative 5, that's negative 3 plus 5, that's going to give us a 2. Negative 1 minus negative 3, that's going to give us a 2. 1 minus negative 1, 2, 2. So in this case, second differences are the same. So since the second differences are constant, we can say that the relation is quadratic. Let's draw it in. Okay? So we have negative 3 all the way down at negative 9. We have negative 2 at negative 4. Okay, we have negative 1 at 1. And we have, oops. Yeah, that's right. Negative 1 at 1. 0 at 0. And then 1 at 1. Right? 1 over, 1 up. No, I made a mistake here. What did I make a mistake? Oh, I was backwards completely. I had my whole thing flipped upside down. Let's try this again. Go away. There we go. Let's try this again. Negative 3 all the way up here at 9. That's why everything was looking a little awkward. And then negative 2 at 4. There we go. Negative 1 at 1. 0 at 0. 1 at 1. And 2 at 4. Now I could go to the next one. We all know full well that it's going to be up here at 3, 9 again. But we only have these points, so I'm just going to draw these ones in. Do the best you can to make the line fit. Label everything. Y is equal to x squared. This is the x-axis. This is the y-axis. Great. So we can see that this is clearly not a line. It is clearly quadratic. And we know that for a fact because the degree has a degree of 2. So we know that it is quadratic. Okay. Let's keep on going. We got a few more still that we're going to go through. 4 more to be exact. Alrighty, let's just see if I can get both of these on one line here, on one page here. Close. All right, so this is really just more of the same. Now, what you have to realize is that this negative applies after the square. It's not part of the x. It's negative x squared. So we have negative 3. That's going to be squared and give us 9. Then we apply the negative. So now we have negative 9 plus 3 is going to give us negative 6. Negative 2 squared, that's 4. With the negative, that's negative 4 plus 3 is going to give us negative 1. And we're going to keep going. We're going to get 2. We're going to get 3. We're going to get 2. And we're going to get negative 1. Okay. You'll notice in these quadratic versions, the ones with a degree of 2, that we can see that the numbers almost kind of pivot around a certain value. It finds like a middle value, and then the numbers are identical on either side. We call that symmetry, right? It's symmetrical on both sides. So let's calculate our first differences. Negative 1 minus negative 6, that's 5. 2 minus negative 1, 3. 3 minus 2 is 1. 2 minus 3 is negative 1. And negative 1 minus 2 is negative 3. So definitely not a constant first differences. Let's do the other one. 3 minus 5, that's negative 2. 1 minus 3, negative 2. Negative 1 minus 1, negative 2. And negative 3 minus negative 1, negative 2. So we have second differences again. So since the second differences are constant, that means the relation is quadratic. Okay, so we can graph it all in. This is going to be my x-axis. This is going to be my y-axis. Negative 3, negative 6, all the way down. This time it actually is down. Okay, negative 3, negative 6. Negative 2, negative 1, right about there. And then negative 1, 2, right here. And then 0, 3. Looks like we've hit our pivot point because the next one's at 1, 2. It's coming back down again. And then 2, negative 1. Again, you could draw the whole curve. Okay. Or you can just draw what you have here. In this case, this is going to be y is equal to negative x squared plus 3. Great. So far, so good. We know everything about this. It's pretty easy to tell. It's just all you can see here is that the equations are getting slightly more complicated each time. Let's look at the next one. Y is equal to 2 times x squared minus 8. I'll do the first couple with you again. So negative 3 squared, that's 9. 9 times 2 is 18. 18 minus 8, that's 10. Oh, let's do the next one. Negative 2 squared, that's 4. 4 times 2 is 8. 8 minus 8 is 0. And you're going to keep going. You're going to end up with negative 6, negative 8, negative 6, and 0. We can see that it kind of pivots around this point again. So we see the numbers are symmetrical around both sides. If we had another value, if we went for 3, we'd end up with a 10 there. So first differences. 0 minus 10, that's negative 10. Negative 6 minus 0, that's negative 6. All right, we already know that the first differences are not going to be what we're looking for. So it's definitely not constant there, so which means it's not linear. Negative 8 minus negative 6, that's going to give us negative 2. And then we have 2, and then we have 6. Okay, second differences. Negative 6 minus negative 10, that's going to give us 4. Negative 2 minus negative 6, that's going to give us 4 as well. 2 minus negative 2, that's 4. And 6 minus 2 is also 4. So we see second differences. This tells us, since the second differences are constant, that means the relation is quadratic. We can graph it in, our x-axis, our y-axis, and now let's put it in there. Negative 3 all the way up at 10. Negative 2 at 0, oh, way the heck down here. And then we have negative 1, negative 6, way down here. And then 0, negative 8, that went down fast. And then 1, negative 6, oh, we're coming back up. And then we have 2, 0. This one's going to be tricky to draw. Not my best work. And then we have y is equal to 2x squared minus 8. Okay. 2 more to go, and then that'll be the end for this lesson. So hopefully these are starting to come a little bit quicker now. And it's all just a matter of substitution, substitution, substitution. Okay? Alrighty. So this one, now you got to be careful. You got to follow order of operations. Bedmas. Bedmas says brackets first, then exponents, and then multiplication. So -3 plus 1, that's -2. Squared, that's 4. With the negative, -4. You have to go through all the steps. -2 plus 1, that's -1. Squared, that's 1. With the negative, -1. Okay. -1 plus 1, that's 0. 0 squared is still 0. 0 times -1 is still 0. Not getting away from that one. 0 plus 1 is 1. 1 squared is 1 times -1 gives us -1. Oh, I was looking at the wrong data here. -1 here. And then we're going to keep going. We're going to get -4, and we're going to get -9. Calculating our first differences. -1 minus -4 is going to give you 3. 0 minus -1 is going to give you 1. -1 minus 0 is just -1. Sorry, the previous one was just a 1. -4 minus -1 is going to give us -3. And -9 minus -4, -9 plus 4 is going to give us -5. Not constant there. Okay, how about second differences? 1 minus 3, that's -2. -1 minus 1, also -2. And then -3 minus -1, -2. And -5 minus -3 is also -2. All right, so second differences. The second differences are constant. That tells us that the relation is quadratic. Okay, we can graph it. We got -3, -4. Way down here. We got -2, -1. We got -1, 0. 0, -1. Oh, we've turned it back around again. And then 1, -4. And then 2, all the way down at -9. Okay, so we can graph this thing to the best of our ability. Label your axes and label the relation. Y is equal to -x plus 1 all squared. All right, we got one left. One left. So it's still just more of the same. Just remember, you follow your order of operations. So we're going to substitute that -1 in there. -1 minus 2, that gives us -3. Square that, now we're at 9. 9 minus 4, that's going to give us 5. 0 minus 2, that's -2. Squared, that's 4. 4 minus 4, that's 0. Oh, all right. 1 minus 2, that gives us -1. Squared is 1. 1 minus 4 is going to give us -3. Keep going, you're going to end up with -4, -3, and 0. So we can see that we have a turnaround point again. Okay, let's do our first differences. 0 minus 5, that's -5. -3 minus 0, that's -3. -4 minus -3, that's going to give us -1. And -3 minus -4, it's going to give us a 1. And 0 minus -3 is going to give us a 3. Not constant. So let's do our second differences. -3 minus -5, that gives us 2. -1 minus -3, 2. 1 minus -1, 2. And 3 minus 1 is 2. So we have second differences again. So since the second differences are constant, that means the relation is quadratic. Let's go draw it in. So we have -1, 5, all the way up here. 0, 0, right at the origin. 1, -3. 2, -4. And then 3, -3. Oh, we've looped back again. And then 4, 0. Let's try and connect the dots. There we go. Label everything. Y is equal to x minus 2 all squared minus 4. Label your axes. And that is it. Now there's a little point down here. If both the second and first differences are not constant, does that mean anything? Yeah, it means the relation is neither linear or quadratic. What else could there be? There's lots more things. Come back to more of those later on in the semester, and you'll see that throughout the rest of your mathematical career. So we're going to stop there, and on the next topic, we're going to look at properties of quadratic relations. This will be a little bit more interesting, I think.